Let's take a look at our third example here. We've got the integral of sine 3x and then e to the x dx. Now we want to use, and it tells you, it gives you hints, as you use integration by parts. I'm going to set, what am I going to do? Red, I guess. Okay, set u equal to sine 3x and dv is equal to e to the x dx. I shouldn't do those in red. Excuse me. du, the derivative of sine is cosine, but since it's more than just an x here, you have to use chain rule. So you have to multiply times the derivative of what's following this. So this would be 3 cosine 3x dx. Now v would be the integral of e to the x dx. So integral of this, which is e to the x. Okay, so this is past 1. So our formula for integration by parts, again, this is u, and this right here is dv. Our formula is uv minus the integral of v du. So let me plug in our values. So we've got the integral of sine 3x e to the x dx is equal to u, which was sine 3x, times v, which was e to the x, minus the integral of v, which was e to the x. Except I'm not going to put it first, I'll put it after. du was 3 cosine 3x, and here I'll put the e to the x and then dx. So again, what I did is, here's v, I just put the e to the x at the end, and du is the 3 cosine 3x and dx. Okay, so this gives us the integral of sine 3x e to the x dx is equal to, and I'll leave it in that form temporarily. So sine 3x times e to the x. Take that 3 out in front, so we got minus 3. The integral of cosine 3x e to the x dx. Now we want to use integration by parts again. So this is going to be our u, and this is going to be our dv. So I come over here, this will be past 2. So we said u is equal to cosine 3x, dv is equal to e to the x dx. Well, derivative of cosine is negative sine, but we have more than just an x here, so you have to multiply times the derivative of this, which would be 3. So we're going to have negative 3 sine 3x dx, and for v we'll take the integral of that, which just gives us e to the x. And this is past 2. And I guess I did it right down here. Okay, so we got the integral of sine 3x e to the x dx. The reason I write in this form, usually the e to the x is put first, is your e to the x dx is always your dv. That's why I want to leave it in this form to begin with. Okay, equals, and then we got sine 3x times e to the x minus 3, and this will be uv minus the integral of v du. That's the integration by parts. Well, u was cosine 3x, v was e to the x, minus the integral of v. Again, I'm not going to put this in that form though. Let me do my du first. I'll put the negative 3 sine 3x, and then I'll put the v, e to the x dx. So see again, I put the v right here, the negative 3 sine 3x, negative 3 sine 3x, and the dx are still there. Okay, so we've got sine 3x, e to the x dx, and here I'll flip those around. I'll put e to the x here and sine 3x, and now I need to multiply this negative 3 through. So I got negative 3 we flip those around. I'll put the e to the x first. So negative 3 e to the x cosine 3x, and negative 3 times a negative gives us a positive 3 in that integral. E to the x dx. There we go. Okay, that was just taking negative 3 and multiplying it through. So then we got the integral of sine 3 to the x e to the x dx is equal e to the x sine 3x minus 3 e to the x cosine 3x. And this negative 3 I can bring out in front now, and that gives me a negative 9 integral of sine 3x e to the x dx. Now look at what we're solving for here. This is what we want to find. Look exactly what it looks like. Look at this over here. Excluding the number that's out in front, we got the integral of sine to the 3x e to the x dx. That matches that exactly, right? What we're doing with this is we're going through enough passes to try to get an integral on the right side that look like this on the left side, which we just did. So you treat this like a variable. I'm going to take this negative 9 integral over to the left side. So this becomes the integral of sine 3x e to the x dx. Negative 9 becomes a positive 9 integral of sine 3x e to the x dx equals, and then we're left with this over here. So we got e to the x sine 3x minus 3 e to the x cosine 3x. Well, this is like items. These integrals are the same, so I can add the numbers that are out in front of them. Well, out in front of this one is the invisible 1. So we've got 1 plus 9 gives us 10. Integral of sine 3x e to the x dx equals e to the x sine 3x minus 3 e to the x cosine 3x. Now I want to get rid of this 10 here, so I'm going to multiply both sides by 1/10. And then we're going to have the integral by itself, and that's what we were solving for initially. So I'll multiply both sides by 1/10. E to the x sine 3x minus 3 e to the x cosine 3x. Those 10s cancel, and we got the integral of sine 3x ex dx is equal to, and you could factor out the e to the x if you wanted to, and then that'd leave us sine 3x minus 3 cosine 3x, and I'll put a plus c on here at the end, but that would give us our answer. So again, we went through and we had to do it a couple times, and the reason what made me know that I have to do this is because if you're taking the derivative of sine, goes to cosine, cosine goes to sine goes back to cosine, so it flip-flops back and forth forever with some negative sign changes. Now e to the x. The integral of e to the x is e to the x. The integral of e to the x is e to the x. So it goes forever. So there's no way you can actually solve the problem with normal means. You have to use this little trick here. Integration by parts with a normal formula only works if by taking a derivative or the integral of one of these, it helps for it to disappear. For example, if this was an x, well, the derivative of x is 1. So anyway, that's that problem.